All right, so we are going to go through and do some examples of functions and inverse functions. So this question simply states, is this one-to-one? So your question is, do any of your x's repeat? So do my x's repeat? If my x's do not repeat, then I have a function. So I've got A, B, C, D, E, F. So this thing is a function. No x's repeat. What about y's? Do any of your y's repeat? So I don't see any other 1370s. I don't see any other 758s. No more 1084s. No 638s. No 1084s. There is a 1084. Okay, so since that repeats, this thing is not one-to-one. I have repeating y's, which means he will fail the horizontal line test. Okay, so your criteria for a function is no repeating x's. Your criteria for one-to-one function means there cannot be repeating x's or repeating y's. So he is not a one-to-one function. All right, so is this thing one-to-one? So again, our question is, does he pass the vertical line test? And he does, so I can draw an infinite number of vertical lines, and each one will only hit the graph once. And then what about the horizontal line test? The horizontal line test will ensure that we have no repeating y's. So I'm good, I'm good, I'm good. Now I fail. So I have repeating y values. So he fails the horizontal line test. So this is not one-to-one. Let's try another one. Well, what does this make? So this time I don't have a picture. So I can look at this one of two ways. I can look at this graphically. And so if we draw a picture, this is a, that was a really bad drawing. This is a vertical or a diagonal line. So if I've got a diagonal line that slices through the y-axis at -3 and has a slope of +2. Okay, so it looks somewhat like that. So does he pass the vertical line test? Yes, he does. He is a function. Does he pass the horizontal line test? Yes, he does, because every horizontal line will hit the green thing a max of one time. So is this one-to-one? Yes, it is. Well, what if we don't know that that's a picture of a line? Then what are we going to do? What we're going to do is ensure that every x can only spit out a single y value, and every y can only correspond with a single x value. Okay, so there's no way to create multiple y values. So let's try another one where it's not as straightforward. So we're going to go this way. And then I've got a 3x to the third minus 10. So looking at 3x to the third minus 10, what do I do if I graph it? Well, it's going to drop down 10 units. And it's going to stretch by a factor of 3. So he looks like this, and this is smoother than that, sorry. So is he a function? Yes, he is. So he passes the vertical line test. Does he pass the horizontal line test? Yes, he does. And so every x value corresponds with one y, and every y value corresponds with a single x. So he passes both, so he is one-to-one. All right, so is this one-to-one? Well, what does this make if I graph it? If I graph this, my parent function is stretched by a factor of 2, and it has gotten shifted to the left 5 and down 7, and he is a parabola, and he got shifted, or he got stretched by a factor of 2. So he's tall and skinny. So what do you have here? Your parent function is a parabola. So does he pass the vertical line test? Yes, he does. Does he pass the horizontal line test? No, he does not. So he fails because I've got multiple y values. Okay, I have repeating y values. And how do I know that? Looking at the graph, or sorry, looking at the equation. If I come back over here and look at the equation, I've got an x plus 5 squared. So whatever my x does, if I were to take square roots, I would have positive. I would have 2 y values for every x. All right. Or I'm sorry, I would have multiple. I knew that didn't come out right. I would have repeating y values. Repeating y values. So now I want to determine if something is a function or not. So looking at this, is this thing a function? So I want to go back to my initial statement way back in the first video, and I would like to know, do my x's and y's flip-flop? So looking at this, I've got a -1, -4. Do they flip-flop? Yes, they do. -4, -1. So far they are inverses. So check the next set. I got -4, -3. -3, -4. They flip-flopped. So far he's an inverse. So try another one. I got 5, -5. So this is -5, 5. So they have flip-flopped. So yes, these two are still inverses. And now let's try the last one. And I've got 2, -1, which is -1, 2. So those have also flip-flopped. And so because all of my x's and y's flip-flopped, these are inverses of one another. All right, so I want a function defined by the following is 1 to 1. I'm told it's 1 to 1, so now I want to find its inverse. Well, how do I find an inverse? I flip-flop its x's and its y's. Okay, so I'm going to have 3 points because my original function had 3 points. My first point is a -3, 7. So I'm going to flip-flop it and do a 7, -3. My second point is a 3, 1. So I'm going to flip it and do a 1, 3. My third point is a 4, 8. So I'm going to flip it and do an 8, 4. And so that is my inverse function. So that is 1 to 1. And then we have, all right, graph the inverse of the given 1 to 1 function. So what I would like is for this thing to be reflected across the line y equals x. Sorry, lost control of my brain. All right, so a way you can do this is to find points and flip-flop them. So I'm going to use this point, this point, this point. I'm just finding pretty points. This point, and it looks like that point. And I'm just going to flip-flop those. So what I have right now is a 0, 0. I have a 2, 1. I have a 4, 4. And I have a 6, 9. So my inverse is going to be the flip-flop of those. So how do I flip-flop 0, 0? It's 0, 0. How do I flip-flop 2, 1? It is 1, 2. How do I flip-flop 4, 4? It's 4, 4. And how do I flip-flop 6, 9? It is 9, 6. So I'm going to have this point. I'm going to have 1, 2. I'm going to have 4, 4. And I'm going to have 9, 6, which is going to be right there. So what I'm looking for is that shape. And now if you'll notice, it is symmetric across this line. So if I were to fold this on the line y equals x, those things would lay on top of one another. So now you can figure it out from there. All right, because only one of those looks like that. All right, so we have another one. I have this, graph the inverse of the 1 to 1 function. So again, I'm just going to find some pretty points, and I'm going to flip-flop them. So what I have so far is, here's a pretty point, here's a pretty point, and here's a pretty point. Okay, so what are those points? 0, 0. And -1, -3, and 1, 3. So I'm going to flip-flop those. So now I've got the point 0, 0. I've got the point -3, -1. And I've got the point 3, 1. So there's my 0, 0. Here's -3, -1. And here's 3, 1. And remember that he is going to be symmetric across the line y equals x. So that's a pretty crappy drawing, sorry. And so if I were to have the line y equals x, it would look like that. Okay, so just grab some points and flip-flop them, and then go from there. So our last one is graph the inverse function. So choose the correct graph on the right that shows the inverse as a dashed line. Okay, so we're going to do this one at a time. If I look at this one, this is a possibility. So I'm going to start grabbing some points. The reason I think it might be a possibility is because if I do the diagonal, it might work. Okay, it might not. It's kind of fuzzy. So that's a possibility. What if I do this one? That's a diagonal, so it might work. What do I mean by a diagonal? If I draw a diagonal straight through, that one looks like it might work. And then look at this one, X I said. Okay, these ones are parallel lines, so that's not going to pass that diagonal test. In other words, your X's and Y's didn't flip-flop. And then this one, that is just way far up in the sky. That doesn't make sense. Because if I have my diagonal line this way, that is not going to be symmetric across that line. So looking at these, I'm going to go back and choose option B, and I'm going to see if my original is blue. So here is the point 0. What just happened? Here is the point. I keep forgetting to zoom in. Here's the point 0. What point is that? 0. That's a 10, 8, 7. So 0, -7. And then I've got another point that we can find. This looks to be about 3/4. So 0 and 3/4. And so let's flip-flop those. If I've got -7, 0, and 3/4, 0, and remember those are kind of approximate. So -7, 0 is going to be right there. And then 3/4, 0 is going to be right. Sorry, I just flip-flopped it in my brain. I flip-flopped it backwards. Dadgummit. It's not 0, it's 3/4. This one was, I just totally screwed that up, and I'm not recording this whole thing. All right, so hang on, go back over here. This point right here is 3/4, 0. So when I flip it over here, I end up with 0, 3/4. Which I'm like, wait, that point's not there. All right, so 0, 3/4. So when I do that, that point is right there. So this is an amazing reflection across y equals x. And I totally butchered that last problem, sorry. But there you go, that is 4.1.